Good morning, distinguished resource person, Principal, National PG College, Professor Devendra Kumar Singh sir, Professor Ram Krishna sir, Head Hindi Department, research scholars and all participants. We are here on the third day of our AICTE sponsored Advanced FDP program on harnessing the digital revolution for business, education, and societal sustainability. As we move into fifth session of the FDP, we now turn our attention to one of the most informative forces reshaping global industry today: intelligent automation, connected system, and robotics in industry, which we can say in common sense, common language, industrial revolution. From the self-optimizing production, supply chain, linings, and collaborative, seamless human efforts, this revolution is redefining what manufacturing and efficiency means in 21st century. And there could be no better guide to talk on this topic through this landscape, our subject expert, Dr. Ravi Prakash Verma. It's my privilege to introduce to you Dr. Ravi Prakash Verma, a name that needs no introduction to many in this room, given his long-standing association with academic excellence in computer science and artificial intelligence. May I request Professor Devendra Kumar Singh sir to kindly felicitate Dr. Ravi Prakash Verma sir with the memento as a token of our gratitude and respect. मैं प्रोफेसर राम कृष्ण सर से भी निवेदन करना चाहूंगा कि वो रवि प्रकाश सर को प्लांट थैंक यू सो मच सर। मैं महाविद्यालय के प्राचार्य प्रोफेसर देवेंद्र कुमार सिंह सर से निवेदन करूंगा कि वो आज के विषय आर्टिफिशियल इंटेलिजेंस, ऑटोमेशन पर अपने दो शब्द से हमें अनुरोध करें।
बोलने के लिए तो आप बोलेंगे, क्या बोलेंगे
सर जैसा आप कहें। ओके। डॉक्टर रवि प्रकाश वर्मा सर इंडस्ट्री में 24 साल से ज्यादा का अनुभव लेकर आते हैं। He is currently serving as Professor and Head, Department of Artificial Intelligence and Data Science, IIMT College of Engineering, Greater Noida. Over the years, he has held distinguished academic and leadership positions at institutions like ABES Ghaziabad, BBD University, Integral University, Rama University, Ambalika College, Lucknow, and many others. A prolific researcher, Dr. Verma has authored numerous publications including Scopus Indexed and IEEE journals. He edited academic books, published various chapters in books. What makes today's session even more special is that this is not Dr. Verma's first engagement with National PG College. He has previously conducted a session, and let me clarify, it was a wonderful session on ethical application of AI in research during our earlier basic Atal FDP program in 2024. We are therefore delighted to welcome him back to our campus may request Dr. Ravi Prakash Sharma sir to enlighten us on Industry 4.0, smart factories and robotics, which is our topic for the session. Sir, please.
बैठिए इधर बैठिए
बैठो तिवारी जी आप बैठो
Good morning, everybody.
Good morning, sir.
And I'm very delighted and I'm very honored. And it's been privilege while taking session in National PG College, because I've been twice invited in the Atal FDB program. And as if you remember my previous session, now I worked very hard to keep things simple and easy for us, so that we can have a better understanding of what is going on in Industry 4.0 and in robotics. Okay, so we'll keep things very light. Okay, and wherever you feel like some doubt or query, you can inject yourself in the discussion itself, and please be attentive, because I have a habit of keeping my audience engaged. So be attentive, and let's begin with the session. Okay, so Industry 4.0. So and that means smart factories and robotics. So we are a developing country. Some parts of India have been developed to a scale of they match the world class infrastructures. But if you talk about country as a whole, so country lags. Okay, so there are two sides of the coin. One is we have poor India, and other is very developed and high-tech India. Okay, so the Industry 4.0 is actually something which have been imported from West. Okay, but the experts agree that if you want to foster ourselves into some developed league of nations, so we should have Industry 4.0. So those students, teachers, and others who are planning to actually do something in needs to manufacture or helping the students for startup, you have to actually keep Industry 4.0 standard in your mind. Okay, and robotics. It does not mean that how cheap labor is available in your locality, but to match the global standards, you have to actually work with robotics and Industry 4.0. So let's begin. So the agenda would be introduction, industry evolution, core technologies, smart factories, robotics, case studies and research discussion. Hands-on activities are there, but I'll try to reach on the hands-on activities. But if not possible, then all the above mentioned topics are self-sufficient. So our learning objective would be understanding Industry 4.0, exploring the smart manufacturing, learn robotics and integration, and realizing the real-world applications. So we all know that fourth industrial revolution is all about physical production system with digital technologies, and the key drivers are artificial intelligence, Internet of Things, big data analytics, and cyber physical systems. Okay, And there have been many evolutions. We will be covering all of them. Yeah, we will be covering all of them. And it focuses on real-time discussions, decision making, and autonomous or in machines. So digital transformer of manufacturing means smart factories. Smart factories means where the system, machine, the expected output, and the humans, workers, are all interconnected. Machine understands human, humans understand machines. Okay, that is a smart factory. Now, production processes are enhanced to real-time data collection, predictive maintenance, automation with intelligence robots, cloud and edge computing. And this leads to efficiency and production quality, flexibility, decision making, and innovation. You take about any aspect of managing production, Industry 4.0, okay, and smart factories are able to do so. Let's see how. So we have we are in fourth revolution. So first revolution was steam. Earlier, whatever the industry used to operate, they used to operate on the manual work. There is set of laborers coming in, working with small tools of machines, and there is no automatic process. Then steam engines came into the existence, and a steam engine actually moved the pulleys and the wheels of industry. Okay, and then we have that big revolution. We had merely textiles and other things available at a cheaper rate. Then we have Industry 2.0. Since steam was causing problems like pollution, accumulation of coal, okay, burning of fossil fuels. So electricity was much cheaper, very efficient, less noisy, and easy to handle. Okay, so in Industry 1.0, we had a steam engine. That means basically a set of boilers. Boilers used to drive the engines, and then your production used to take place. So there were three sets of problems for that: managing the fuel for the boiler, managing the steam engine, steam production, and then you may have to manage your own production and machines. So this was reduced with the help of electricity. You can establish your industry anywhere because electricity is readily available and easily available, accessible. So you have to just focus on your machines which are producing. Then 3.0 is all about automation. So everything was automatic, and that also helped us a lot. And then was 4.0 means digitalization. So we will be covering digitalization more. So let's see this graphics. It was started in 18th century, steam engine introduction. Okay, so this basically transformed the production. Then till late 18th century, okay, you have mechanized manufacturing. So the output was textile and iron growth. Okay, so both these two industries flourished, and that was the basic demand of that era. Then in late 18th century, electricity revolutionized everything. Assembly lines and innovation was made. Okay, so for example, Ford's assembly line for Model T. Okay, so Henry Ford came up with the production of cars, and mass production was achieved because electric power and assembly lines were able to produce the parts and machinery at a very fast rate. And in fact, Henry Ford has a vision that everybody on this planet should have its own personal car. Okay, so that was his motto. Now we have Industry 3.0. So we have automation, we have introduction of computers, PLCs, programmable logical controllers, robotics in manufacturing. And so in late 20th century, we were able to do repetitive tasks. Okay, a task which is repetitive, and the efficiency increased, the production increased, the cost of the production came down. And then we have precision and consistency, because machines are doing something, so things would be very precise. Okay, like manufacturing prototype. So we have a boiler plate. That boiler plate means we have a die that is manufacturing. Something is being manufactured with that die. So you see for example, your cup of tea. They are of same size because it is made from the die. No humans are not directly making that cup of tea. Machines are doing for you. So every cup is precise of same size, have same volume, and so on. So production is fast, and that is why it is very cheap. You use it once and throw it off. Okay, no need to wash it again. Utensils. You remember having tea on in a cup, in a small glass. Okay, at tea shop.